In this video, we are going to discuss about the questions which have come in JEE Mains 2023. To begin with, the first question gives us the fact that to find the ratio of displacement to distance traveled by a body between 0 to 10 seconds. Displacement is positive or negative, whereas distance is always positive. The velocity time graph, the area under the curve is displacement or distance. The region 1 and region 2 are 16 meters respectively, whereas the region 3 and 4 are -8 meters respectively. Therefore, the ratio of displacement to distance comes out to be 16 divided by 48, which is equal to 1 by 3. In this question, it has been given that a car travels a distance x with speed v1 and the same distance x with speed v2. We require to find the value of average speed. Let t1 be the time required to cover distance x with speed v1 and let t2 be the time required to cover the distance x with speed v2. So time t1 is equal to x by v1 and time t2 is equal to x divided by v2. By definition, average speed is equal to distance upon time. Therefore, average speed comes out to be equal to 2x divided by t1 plus t2. Substitute the values of t1, t2, we get the average speed to be equal to 2v1, v2 divided by v1 plus v2. In this question, it has been given the relation of displacement or distance x is equal to 4t square. We need to find the value of velocity. Differentiating the above equation, we get dx by dt equal to 8t. By substituting the value of t equal to 5 seconds, we get the velocity v to be equal to 40 meters per second. In this question, it has been given that a tennis ball is dropped on the floor from a height of 9.8 meters. It rebounds to the height of 5 meters after it comes in contact with the floor. The ball is in contact with the floor for 0.2 seconds. We need to find the average acceleration during the contact between the ball and the floor. Let v1 be the velocity when the ball reaches the ground and when v2 be the velocity when it rebounds. By definition, the average acceleration will be equal to delta v by delta t. When the ball hits the ground, the velocity v is given by root of 2gh. And when the ball rebounds back to height equal to h dash, the initial velocity will be equal to root of 2gh dash. Taking the difference of these two velocities, we get the value of acceleration to be equal to 120 meters per second square. This question is about match the columns. The column 1 is xt graph and column 2 is a vt graph. When you try to see the first entry A under the column 1 graph, xt graph, the x increases non-linearly. The gradient of that value will be increasing linearly. Therefore, for A, the option is 2. For B, the displacement keeps on decreasing non-linearly. Hence, the velocity will approach 0, option number 4. For C, the displacement increases linearly and then decreases linearly. Here, the answer would be velocity is positive as well as negative but constant, option number 3. And D, the displacement keeps on increasing linearly, therefore the velocity will remain constant. Hence the answer overall will be option number 1. In this question, a horse rider covers the first half distance with 5 meters per second and the remaining half distance is covered in equal interval of times t1 and t2 with speeds 10 meters per second and 50 meters per second respectively. The mean speed of the rider is given as x by 7 meters per second. We require to find the value of x. First and foremost, the distance covered in the first half, S is given as velocity times time. So S is equal to 5t. Since the time intervals are equal in the second half, the average velocity comes out to be equal to 10 plus 15 divided by 2, which is equal to 25 divided by 2. Hence, the second half distance S will be equal to 25 divided by 2 times t1. The mean speed is equal to total distance divided by total time, which is equal to x divided by 7 equal to 2s divided by t plus t1. Substitute the value of t and t1, we get the value of x equal to 50. In this question, we have to find the average speed. It is fairly straightforward. The vehicle travels 4 kilometers with speed of 3 km per hour and another 4 kilometers with speed of 5 km per hour. Need not try to change the units because the answers are given in kilometer per hour. By definition, average speed is equal to total distance divided by total time. Therefore, V average is equal to total distance is 8 kilometers, total time is t1 plus t2. Substitute the values of t1 and t2, we get the value to be equal to 3.75 kilometer per hour. In this question, a body is moving with constant speed in a circle of radius 10 meters. The body completes one revolution in 4 seconds. We want to find at the end of the third second what is the displacement. To begin with, the position of the particle after 1 second will be 1/4 of the circle. So after 3/4 of the circle, the time will be equal to 3 seconds. Therefore, the position of the particle will be as shown in the diagram. The displacement is the direct distance between the initial point and the final point as shown in the figure. Therefore, the body covers a distance s or displacement s will be equal to square root of 2r square. R is given as equal to 10 meters. So substituting the values, we get the value of displacement s to be equal to 10 root 2 meters. This question is fairly direct. The distance AB is equal to distance BC is equal to distance CD. Therefore, the average velocity will be equal to total distance divided by time. Time for each intervals will be equal to x divided by v1, x divided by v2 plus x divided by v3. The average velocity comes out to be equal to 3v1 v2 v3 divided by v1 v2 plus v2 v3 plus v3 v1. In this last question, it has been given that a train engine is moving with a speed of 20 meters per second. When the driver applies the brake, the distance covered by the train is 50 meters before the train comes to halt. If the brakes were applied at half of this distance, that is 250 meters, then the engine would cross the station with speed equal to square root of x. We need to find the value of x. To begin with, first and foremost, we take the equation v square is equal to u square plus 2as. The final velocity v is 0, hence we determine the deceleration of the engine, which is a is equal to u square divided by 2s. We substitute the values and get the deceleration to be equal to 0.4 meters per second square. We again use the equation v square is equal to u square plus 2as. Now the distance traveled by the engine is 250 meters. The deceleration is already known to us, 0.4 meters per second square. We determine the value of v, which is equal to square root of 200. The value of x therefore will be equal to 200.